I got you, Vinci. So sometimes we need to compute these kind of integral. With this one, x integral of x square root of a square minus x squared dx here seem to be easy. If you have to do this problem, what should we do? Any idea? Louder, please.
Make u equal to
X squared, right? Then we take derivative. It will be 2x dx. We can do it in our head now. We can try. Then, yeah, the whole thing here is a lot easier, even more. So then we can do substitution. But if we want to compute integral of square root of something squared here itself is even harder. Okay. So in order to solve these kind of problems, we use a properties of trig identity. We know that sine square plus cosine square of any angle theta will be always be 1. So therefore, 1 minus sine square theta, you see, is equal to, what is it? Cosine square theta, right? This kind, yes, Luke.
On the, I guess on the sheet, I'm just wondering how it got from the first line of the x squared minus a squared times theta to the second line of the x squared times 1.
From here to here?
Yeah.
We'll go through that. But before doing that, I would just want to mention the easy one first. Okay, thank you. So if somehow we define the variable x is sine theta, right? Then this function becomes 1 minus what? X squared, right? Ignores the right-hand side. Let us talk about the left-hand side. Okay? So, therefore, in the future, we do the reverse situation. If we're given 1 minus x squared, we will define x to be sine square theta, right? Then we go backward and we replace this. How about, how about we are given 2 minus x squared. Can we write this guy in terms of theta, sine theta and cosine theta? From this one.
Does the first term have to be a square?
Yes, the first term is should be something square, right? Very good, corner. Thank you. Oh, I'm sorry. Wally, yeah, with your mask and is yeah. Thank you. So this guy, 2, we can write it as yes. Right. Very good. So, And x squared here, what should we define? We need to write something in terms of theta, for example, right? With a parameter somehow right here. And in your point of view, what should we place here? So that in the next step, we can factor it out and make it easier. Let us try. Let us try. We don't know. Let us try with x is equal to 3 sine theta, right? Or let us play with 2 here. Then 2 minus x squared is square root of 2 squared here minus 2 sine theta squared. What does it mean? Or this is simply 2 minus, what is it? Yeah, 4 sine theta here. But if we do it here, thank you for your contribution, Audrey and yeah, Lindsay. But here, we got stuck, right? Because 2 and 4, we cannot factor it out. So the better choice would be if x is this guy, right? X is square root of 2 sine theta, then this guy will be this, right? And therefore, it will be, we can write it as okay. If we write it this way, then can we factor it out? The whole thing's here. What is the like term of these two items? Very good. Thank you, Luke. Yes, it is 1 minus sine square theta. So are you comfortable with this to this point? Yes. Yes, we try to place a parameter here smart enough so that we can do we can factor this parameter out. Yeah, that is the idea. Thank you. What is your name again? Corey. Thank you. Luke Wally. Thank you. So, yes. Yes, because here, we want, at the end, we want to factor a parameter such that the things here is 1 minus sine square. So if, and the target here, we write 2 a square root of 2 square so that we can see this parameter easily, square root of 2 here. We observe that this factor is simply this one, easier to see. Okay? Why? Because when this guy square, it will become this parameter, right? It is nothing else but 2.
So would we always just make it that first term, or is there times that it would be something different?
Yeah, maybe we will see the trick in an abstract case. Okay, for this case, it is simply, or we can write it 2 times 1 minus sine square. Can we write it in terms of cosine? And what is it? Yeah, okay. Remember, if we write x as square root of 2 sine theta, we take derivative with respect to theta of the variable x here. It is the same as t over t theta of square root of 2 sine theta here, right? Therefore, what is it here? Square root of 2 is a constant, right? With respect to the theta variable. So derivative of this guy will be derivative of sine theta, right? We don't have to do chain rule here because you see, yeah, this is sine, right? The variable here is theta, and we're taking the derivative with respect to that variable. So there's no chain rule here. So what is derivative of sine? Cosine, yes. See that if we define x here, we can write these in terms of sine and cosine. So we will somehow manipulate the original variables and write it in terms of a new trig functions here. In general, here, if we are given a term square root of a squared minus x squared, right? The smart ways to define x is this guy. Okay? If x, we define it as a times sine theta here. Then x squared will be a square times sine squared here, right? So we replace it here. Is it clear at this point? Are we good? Then this is a smart choice. And we see that the common factor of this guy is a squared here. So we can factor it out, right? And remember, square root of here, this guy, will replace 1 minus sine square by cosine square here. And the formula tells us that, okay, square root of a times b will be square root of a times square root of b. Okay? And in this case, square root of a, and a is a positive number, for example, then this guy becomes a, right? And square root of cosine square will be the absolute value of cosine. Remember, we should take the absolute value here. Yes. Okay. So we can get rid of this guy. So let us do an example. Okay. Suppose we need to, yes.
I have a question on this, the last one. Do you not have to like take the integral of it?
We will do, this is the trick to get over the radical terms. Then we'll go to a specific problems and see how we can deal with that. Okay? Now, suppose we need to compute this integral. Okay? We see this term we just discussed a few minutes ago. We want to get rid of this guy. And let us do the substitution rule. Okay? Let us define x will be 3 times sine theta. So the original problems is to find antiderivative of this function with respect to x variable. Now we define a new variable in terms of theta. Remember, okay, the sine theta, because in the end, when we compute this in terms of sine theta, we will find some things in terms of f theta. Suppose we found the solution here, right? What we need to do is to write it in terms of x variable, right? It means at some point, we will need to find the theta, the relation between x and theta, if we take sine inverse both sides of this equation. What do we have? Yeah, let us divide by 3 first. X over 3. We know from this relation here, right? And at some point, we need to find theta and x here. We will take the inverse both sides. Sine theta and then inverse of sine theta give us theta. This links us back to the one-to-one function. In order to take the inverse of a function, it should be one-to-one. And one-to-one, it means that, so suppose this is a function. One-to-one, it means that 1x here will define 1y in the range, right? And our function here is the sine function. Suppose this is a sine function. In this case. So let us review the sine properties of sine function a little bit, because we have to. Okay, suppose this is the unit circle. This is the cosine axis. And this is the sine axis here. The value of them will be 1 here. And the angle will be this direction, will go through this direction. It is counterclockwise. It is the positive direction of the angle. So, and the angle start with 0. Angle 0 is right here. And this is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi, so on and so forth. Okay? And the graph of this function, the sine function. So tell me, what is sine of 0? Very good. How about at here, pi over 2? Very good. How about sine of pi? Okay. And sine of 3 pi over 2? -1, right? Very good. Or the graph of the sine function will be like this. Suppose this is the theta angle here. And here, this is 2 pi, this is pi. Sine at 0 would be 0. Sine at pi, suppose 1 is right here. I'm sorry. Oh, sine of pi. Oh, yeah. Yeah, a pi over 2 would be 1. Yes, thank you, Luke. Pi over 2 is right here, right? It's 1. And sine of pi would be 0. Sine of 3 pi over 2, it would be. And sine of 2 pi, go back here, it would be 0, right? And this is the graph of the sine function. It is periodic. So if we, on the left-hand side, it will has the similar shape, right? Like this shape. So it means that if, yeah, it will be repeated. And the sine, okay, let me add one more page here. And we see that sine function here from, we know that sine of theta will be always between -1 and 1, right? At for any angle, suppose theta is here, we project to the sine axis. It will give us the sine of theta. So the sine function here, if the angle theta is from -pi/2 to pi/2, we see that what is the range of sine theta from this is also -pi/2, right? What is the range of sine? Yes, it is from -1 to 1. So if we pick theta from -pi/2 to pi/2, and the range of this function will be from -1 to 1. So it is convenient to define it is 1-to-1 relation. So it is 1-to-1, then we can take the inverse of sine theta. And the inverse function of sine theta will take the range here, and the range of sine will be the domain of the sine inverse. And the range of the sine inverse will be the domain of the sine function. Okay? And the convention is that the domain, the range of, the sine inverse will be from -pi/2 to pi/2. This is a proof, discussion about the sine inverse function, okay? I just want to remind you about this. How about the cosine function? We'll review a little bit about sine inverse and cosine. And here, the cosine function theta, if we see that the unit circle here, cosine, in order to cover from the range -1 to 1 of the cosine here, cosine axis here, the angle theta will go from 0 to 2 pi, right? At cosine at 0, it would be 1. And cosine at pi over 2, it will be 0. Cosine of pi here will give us -1. So if we take the angle from 0 to 2 pi here, then the range of cosine will be from -1 to 1. Therefore, the inverse function of cosine is cosine inverse. It will take the range of the cosine function to be the domain, and the domain of the cosine function would be the range of the cosine inverse. Okay. Quick review about this inverse function. That's it. Therefore, here, if we define x is 3 times sine theta here, the angle will be from -pi over 2 to pi over 2. We pick the one-to-one function, and the range of these will be here. Now we need to find the relation between x and theta. Okay. Okay, let me write it down here. Integral 9 minus x squared divided by, yeah, let me copy it faster. Okay. So we need to find the relation between, oh, interesting. Okay, between x and theta, we take derivative of this guy, d over d theta of x, right? It will be the same as d over d theta of the right-hand side. Do you agree? And what do we have? Yes, 3 cosine here. Very good. So, very good. Therefore, dx is, what is it? Very good. We have the relation here, right? Then, okay, let us write everything here in terms of theta and see what happens. Therefore, the integral I becomes, we write it in terms of theta. This guy will be, we'll replace x by 3 sine theta. It will be, yes, 3 sine theta here, and they're all square. The denominator here becomes, yes, 3 sine theta, they're all square. And dx, we write it in terms of d theta. And it will be, yes. So, do you have any question up to this point? Is everything clear? Very good. Okay. Now, what we need to do is to deal with this integral. Okay, what should we do now? Yes, very good. Let us simplify it. This guy, what is the common things between this things and this thing? Yeah, or we can write it 9 minus 9 sine square theta, right? And here, this guy will be 3 square times sine square, which is 9 sine square theta. And here, 3 cosine theta d theta, we just rewrite it. Okay. the like term is number 9 here. Okay. Then it will be, what is it? Very good. Okay. So, very good. Thank you. So 1 minus sine square here, we can write it as cosine square theta, right? And 9, let us write it as 3 square. Okay. So this product, the product rule and radical sign tell us that this guy would be 3. Yes, absolute value of cosine theta. Okay. 9 sine square theta. 3 cosine theta. D theta, right? Okay. And here, the angle theta is from negative pi over 2 to pi over 2, right? What is the value of cosine? Is it positive or negative? Yeah. We can draw the unit circle here. The cosine axis is this guy. And we pick the angle from negative pi over 2 to pi over 2. Between these values, the value of cosine is always positive, no matter what it is, between negative pi over 2. When we project it here, it will always be positive. Therefore, we can get rid of the absolute signs here, right? Is it clear? Okay, we can only remove the absolute value when it is positive, and it is the case here. Therefore, this guy is 3 cosine theta, and here is 9 sine square theta. Here is cosine theta, d theta, right? So, what should we do? Very good. Oh, yeah, number 3 here. Thank you. So 3 here, multiply 3 here will be 9, and they're all divided by 9. So it's simply, yeah, cosine square. Very good. Thank you. Okay. Now it will be cosine square, sine square. What should we do next? Again, please. Secant square. And if, yeah, we can write it that way, secant square. But if we can find the secant antiderivative of secant square, that is perfect, right? But if we don't remember the formula of that, or we don't know for now, we can do another way. If we write cosine square here is, yeah, let us. This is cotangent, right? Cosine square is cotangent square. Cotangent square. D theta. Look at the table I gave you. Do we have any formula of this, and what is it? Do you find any? If you cannot find it, we can do another way around. Okay, we can find it, then that is perfect. Or if we write this guy is, how about if we break it? Cosine square, we can write it 1 minus sine square here, right? Sine square theta, d theta, if we write this way. And let us see if we can simplify it. Okay. Yes, sine square over sine square will be 1, right? Just a my habit. Sometimes I write 1 is this guy, or sometimes I write it just stroke like this. So forgive me if sometimes I write 1 here and another times I write it this way. It may confuse you, but you understand my handwriting. Okay. And we can also find this integral this way. And the antiderivative of this guy will be this guy, right? One over secant is 1 over sine square is nothing else but cosecant square, right? D theta minus 1 d theta here, right? And we know that derivative of cotangent is negative cosecant square. Therefore, antiderivative of cosecant square is negative cotangent theta. You can double check it at the differentiation table. Okay. Or we can do it together. You want to do it and review that formula? Okay, you can do it. Okay, let us compute the derivative of cosecant, which is 1 over sine. Cotangent is cosine theta over sine theta. Let us find the derivative of cotangent, which is cosine over sine, right? And the formula we use will be this one. And what do we have? Very good. V squared, right? And u in this case is cosine, v is sine, right? Then what do we have? Times, what is it? Okay, and this guy? The denominator? Sine squared, right? So what is derivative of cosine theta? Negative, right? Negative sine times sine, and it will be? Very good. And this guy, oh, yeah, sine prime here. Sine prime give us cosine, cosine times cosine give us cosine squared here. Okay, and this, okay. So if we factor the negative sign, -1 out of this, we will have, what is it in the numerator? Which is? Yes. Then this guy is 1, therefore it will be negative 1 times 1 over sine square theta. It is negative of cosecant square, right? Therefore, antiderivative of cosecant square will be negative of cotangent. Makes sense here. Okay. The more you memorize the formulas, the faster you will be able to do. That's it. And antiderivative of 1, it will be, yes, negative theta. Good job. And what do we need to add here? Yes, a number C, where C is in R. Can we stop here? No, we need to find things in terms of X, right? Very good. How can we do that? Can I erase this side computation? I'm sorry. Oh, okay. This. You're welcome. So out here a little bit. Now let us continue this part. Remember, we define at the very beginning, X is 3 times sine theta. Okay, this implies that X over 3 will be sine theta, right? Yes, very good. How about let us draw a triangle, special triangle. Like this. Suppose it is the angle theta. Okay, it has the hypotenuse of the unit 1 here. And we know that sine of theta will be X over 3. Theta is here, 1 is here. So what is the length of this edge? Yeah, good job. Right, you see it? Sine theta will be opposite divided by hypotenuse, right? And which is X over 3 over 1. This is a trick to make it. And here, this guy is a right angle, right? Pythagorean theorem tells us that this square plus this square will, this square plus this guy's square will be 1, right? Suppose this is B. Suppose this guy is B. We know that X squared, X over 3 square plus B square. Pythagorean theorem tells us that this guy will be 1 square. Therefore, B square will be 1 square, subtract. Yes, X over 3 square here. Then we know that this is the length of this. It is always positive. Therefore, B will be square root of here. It will be 1 minus, let us write it, X squared over 9. Do you agree? Okay, X over 3 squared will be this guy. Oh, we don't have time. So therefore, from this relation, cotangent will be 10 will be X over 3 divided by B, right? Or cotangent will be B divided by X over 3. And B, we found it here. Therefore, we can replace everything in terms of X here. Go home and continue doing these problems. And we'll see you tomorrow. And the next day, we will discuss more about this. Have a good one. See you, everybody.